Assalamualaikum and salam sejahtera. Before we start, let's recite doa first. So today we are going to learn on how to solve the non-homogeneous heat equation by using eigenfunction expansion method. Before this, we have learned on how to solve the non-homogeneous heat equation using decomposition method. But today, we are going to solve this non-homogeneous heat equation using eigenfunction expansion method. Before we proceed, let's recall on the difference between decomposition method and also the eigenfunction expansion method. We use decomposition method when our PDE with non-homogeneous term consists of a constant or one variable only. Okay, like this, where we have only x. We use eigenfunction expansion method when our PDE with non-homogeneous term consists of more than one variables. So in this example, we have f as t, where we have two variables, which are s and t. So before this, for decomposition method, we have v as t and also psi s. But for eigenfunction expansion method, we have u and t and also f and t. Now let's try to solve this example. We have ut as t is equal to u as x plus x exponent to the power of negative 3t. The value of x is in between 0 and pi. So this one is our boundary condition. Based on our boundary condition, we know that this is Dirichlet boundary condition. And the last one, we have the initial condition, which is equal to 0. For the first step, we list our eigenfunction and eigenvalue based on the Dirichlet boundary condition. As we know that for Dirichlet boundary condition, Xn is equal to Cn sine n pi x over L. Then we substitute the value of L, which is equal to pi. Then we just eliminate pi. Then we get Cn sine n s. And then for eigenvalue, we have lambda is equal to negative k square. Then we will have negative n pi over L square. And then just substitute the value of L, which is pi. So we'll have lambda is equal to negative n square. This one is our PDE equation. Now we are going to split this into two. So the left side is referring to the u as t, which is referring to the first formula. And second, we have non-homogeneous term. So we just put it as f as t. This one is referring to the second formula. Okay. In order to satisfy this equation, we must differentiate with respect to t and also with respect to double s. So we differentiate this equation. We have u as t is equal to summation of u and t and our eigenfunction. So our eigenfunction is sine and s. So we just differentiate this equation with respect to t. We will get summation of u prime t sine s. And then when we differentiate with respect to double s, we will get summation of u and t negative n square sine n s. And then for f as t, we will have f and t and then our eigenfunction, which is sine n s. Now let's substitute into our PDE equation, which is ut is equal to u as x plus f as t. So this one will be the ut, this one will be u as s, and this one will be f as t. Then just write it back and we will get this equation. For step 3, we are going to solve the f as t first. So our f as t is equal to s exponent to the power of negative 3t is equal to summation of f and t sine and s. By using Fourier series expansion, we will have f and t is equal to 2 over L integral 0 to L f and t sine and pi s over L ds. And then just substitute our value of L, we will get this equation. So we just solve this by using the integration by parts. So the left one is differentiation, the right side is integration. And then we just substitute the value of integral, which is 0 to pi, and then we will get this one. So sine n pi is equal to 0, and this one is cos n pi is equal to negative 1 to the power of n. So we can just write back and we will get like this. Since we know that negative 1 to the power of n is equal to negative 1 to the power of n plus 1. So we can write f and t is equal to 2 over n exponent to the power of negative 3t negative 1 to the power of n plus 1. So in step 1, we have this formula. So we just equate this sine and s. So we left with u n prime t equal to u n t negative n square plus f n t. But actually we have the general formula. We have u n prime t equal to a square lambda n u n t plus f n t. Now let's just try substitute the value of a and also lambda, which is the eigenvalue. So our a is 1 and our eigenvalue is negative n square. So you can use this step by equate the sine s, or you can use also the general formula because we will get the same answer. Now let's proceed to the next step where we just substitute the value of fn that we obtained just now, where we have u n prime t is equal to negative n square u n t plus 2 over n exponent to the power of negative 3t negative 1 to the power of n plus 1. So we just bring negative n square u n t to the left side and we'll get this one. Okay, since our equation is like this, dy over dx plus p as y is equal to qs. So we need the integrating factor to solve this one. Okay, now let's try to compare this. So we have our dy dx, which is u and prime t, and we have p as y. So our y will be u and t, and our ps will be n square. So the last one is our qs, which is this one. 2 over n exponent to the power of negative 3t negative 1 to the power of n plus 1. Okay, now we have the value of ps and also qs. Now we just use the formula of integrating factor where we have exponent to the power of integral p dt. So we just substitute our value of p, which is n square. So we will have exponent integral P is n square dt. And then just solve this integral. We will get exponent n square t. Next, we are going to use the second formula, which is general solution. So we have u and t times with if equal to integral q dot if. So our q is this one. Okay, now let's just write back. We have u and t dot our if equal to integral. So this one is our q and this one is our if. Okay, now let's put the exponent together to the right side and we just solve this equation. And then the final answer will be this one. For step 5, we are going to use the initial condition on the u as t. So previously we know that u as t is equal to summation of u and t sine and s ds. Since we have the value of u and t, we just substitute into this equation. And then we use the IC, which is u at 0 is equal to 0. Means that we just substitute t is equal to 0. So this one will be exponent to the power of 0. Means that it will be 1. So this one will be exponent to the power of 0. And we will get this one 1. After that, we will get this equation. Since the right side and the left side is same, we just can compare it to get the value of Cn. So by comparison, Cn will be equal to 2 negative 1 to the power of n over n negative 3 plus n square. The last step is write back the full solution, which is u as t. So here is the temperature distribution of non-homogeneous heat equation for this PDE. Okay, that's all for today. Thank you. Have a nice day.